Well, hello everybody, and welcome into Great Atmosphere. Just wanted to get started today by first looking at the current polar vortex as it stands up in the Arctic. Currently, it is centered. You can see it's currently denoted by this big donut here in the lower stratosphere at the 10 hectopascal region. Currently centered over the Scandinavian peninsula, over Norway and Sweden. A little bit displaced, as you can see. It has a major upper level high that is circulating over the Bering Strait and the northwestern parts of Alaska and the far eastern parts of Russia. Those two are working in tandem. They have been working in tandem over the past week or so, and will continue for the next few days to chug all of this cold continental Siberian air over the cold Arctic Ocean and down into the North American subcontinent. But there is a little bit of a pattern change that we're noticing now. We see a series of tiny upper-level lows that are starting to converge, also a major area of convergence on the northeastern side of the Hudson Bay and into the Straits of Canada. They're starting to circulate up in the stratosphere in a cyclonic fashion, which typically indicates the beginning of a blocking pattern that we're going to see, and we can actually see the ending side effect of some of that blocking coming through a weakness of the polar vortex ring as it stands on its southwestern side right here. So interesting little development that we're going to be keeping our eyes on. Another interesting thing that I wanted to show you as we begin is just how cold it is down or up in the Central Plains. So this is infrared. Essentially what this does is the geostationary satellite will take a continuous look at the contiguous U.S., and the louder colors that you see denote colder cloud tops. And if there's any color at all, you would denote that there is cold. There is there is frost. Typically, we reserve those observations for clouds. Obviously, we're looking at cloud tops. But as you can see, this is more. You can see there's quite a bit of purple and blues, especially into the early morning hours of the Central Plains and the Mountain West, on the ground. So we have legitimately tundra atmosphere out in the Central Plains, and we could see that all throughout the course of the week with these -30 wind chills. I know Iowa just had their very consequential political caucus for the Republican Party yesterday, coldest caucus in the history of the Iowa caucuses. It's quite a significant cold snap that we're seeing in that particular region, and it shifted all the way down into Oklahoma, Arkansas, Missouri. It's just kind of interesting to be able to see just how cold it is. That clouds themselves up in the very upper echelons of the atmosphere are just as cold, if not the ground a little bit colder than some of the clouds way up into the sky. Quite interesting, and you can see these are our current temperatures as of 11:30 Central. Still down into single digits all the way down into central northern Kansas, single digits in Missouri, Jefferson City, 12 in central Oklahoma. Even Dallas is not even above 20 right now. The only major line that we see is us here in the southeast. That will change over the next couple of days. We see Atlanta finally shifted over that border of cold and dry versus warm and moist air down to 28. But here in Charlotte, we're sitting nice right now at a nice balmy 44, and the coastline, due to the Gulf Stream, is at 60 degrees. Currently, Miami, actually, in the far southern portions of Florida, has actually started to get close, I'll say, to some daily heat records, actually, due to just being inundated with subtropical jet moisture over this particular region. The jet itself has moved obviously further down south in the recent days, but that jet has maintained its strength over the southern peninsula of Florida. Taking a look at our current radar, you can see where our rain-snow line was going into this morning. Quite a bit of contention among some of my friends and colleagues that live in eastern North Carolina and Raleigh and the Chesapeake Bay region or the Newport News, Norfolk region of Virginia. They are wondering, everything outside looks and feels as though it's ready to snow. I mean, the temperature obviously is only in the low 40s, but why of all things is there not snow in this current setup that we have? If just above them, up to the north in Richmond and the Piedmont of Virginia, it's snowing, right? I mean, they pretty relatable, temperate biomes and whatnot. The only thing that's different really is latitude. Why did they not see snow? So I'm going to do a little bit of a digression here before we get into some of the outlooks forecasting wise, and to kind of discern why we did not see snow. So first, we're going to look at the upper levels. Here we have winds. We have essentially what we're looking at is our upper level jet. This is essentially the primary factor in terms of where we would associate forcing. In this particular one, we are looking for big divergences and pairing jet streams. Primarily, we would want to see a big jet streak right in the center of the main trough that you see in this general region. We do not see that. Most of the primary focus of the jet streak is up here in the upstate of New York and central PA. So generally speaking, that is not what we want. And what we want in that respect is when we have a crux of energy down here at the midpoint of the trough, we start getting that enables diffluence out in the direction of wherever the trough is currently headed. So that is typically what we're looking for, and then we would see isobars and streamlines that kind of go in this general motion. And it's in these areas right here where we would see enhanced vorticity or energy in the atmosphere to be able to kick off strong convection, strong precipitation, ultimately. And that is not what we're seeing here. This is a positively tilted trough. Mainly the precipitation that we've been seeing over the past couple of days has been due to overrunning. So we have a warm nose associated with high pressure that is trying to form at least to our south. And ultimately that is pushing enough warm air underneath so that anything that does fall in the upper levels up here, or the far northern areas, I'll say, anything that falls high in the sky in the upper atmosphere as snow or ice or anything wintry will ultimately just melt as it gets down into this particular region of the southeast. And we can also see that vorticity and that energy here in the 500 millibar geopotential heights and cyclonic vorticity. Not a lot to write home about in terms of energy that we're seeing. A lot of that energy is in that diffluence range, currently over the central Ohio Valley. Not a lot to say in the southeast, so there's not a lot of convection there, not a lot of lift in the atmosphere to be able to get a significant amount of precipitation up into the upper levels. So that's one of the reasons. We can also just look at temperature and that of itself. This is in the mid-levels. They have 3 kilometer temperature with associated wind bars, so we can see a little bit of where that warm advection is coming from. And you can see in this particular region, this is 18Z today, so this is about 1 p.m. We can actually probably move this back a little bit just to be able to see where we were this morning. And you can see that generalized shift that we saw in radar. If we go back to radar, you can see that rain snow line kind of shifts a little bit towards the south and east. And you can see essentially when it gets to the coastline, it starts encountering that Gulf Stream air, that it ceases to exist in that respect. And you can see this here denoted by this red line. That is the freezing level line. So here in the 850 hectopascal range, about, we'll call it a mile up in the atmosphere, mile or kilometer, I'll say. So essentially that is where that's where the dendritic growth zone is for snow and ice crystals. If you are essentially below into the green on this level of the atmosphere, there is pretty much zero chance of seeing any kind of wintry precipitation. Now, it's not essentially guaranteed that you see any precipitation because you still need moisture transport into that particular region in order for snow to even form in the first place in that dendritic growth zone, but it is not definitely for this particular green tier of North Carolina and far southeastern Virginia and certainly South Carolina as a whole. We would not be seeing much of anything. And a lot of this has to do with altitude here in Georgia and then not being shielded by the Appalachian Mountains in Mississippi and Alabama and Tennessee. We can also see various different parameters here with the SPC's mesoscale analysis. We see our freezing level here is denoted. Freezing level is denoted by the big black line. That's what you just observed in the previous guidance we just saw. And then we have our boundary layer. Boundary layer essentially means like 6 inches above the ground, maybe a foot above the ground. So surface level, essentially. And that's ultimately an indicator of if anything is going to stick to the ground or just melt immediately when it gets there. So we're going to go to what we are currently observing here at 0. So we can see that even if snow were to fall in these particular regions, we're probably not going to see any kind of significant accumulation. It's up here in the mountains in the far northeastern areas or far northern areas of DC and Baltimore, where we would expect to see accumulations of snow because the planetary boundary layer is cold enough to put it in there, and or cold enough to be able to keep snow on the ground without melting, and also cold enough to actually form snow crystals in the sky. And we can also see, as a matter of precipitation as well, these purple levels denote whether or not there's enough moisture as a whole in order to make it happen. Ultimately, they're not. I don't know if this particular guidance is at the right level in order to be able to see that, but I would definitely say that the black and the red is a good indicator of temperature and whether or not we're going to see a cumulative snowfall or snowfall at all. And another big part of this is actually the amount of dry air that's being inserted into the system. You can see these deep yellows. These are what we call dry slots. And what dry slots do is essentially, if let's say that it rains, or if it rains or even rains or snows up in the upper levels, we'll call lower levels are usually denoted as anything below 850 millibars to the surface. If there's dry air right above that particular level at the low levels, any precipitation that falls in the mid levels around 500 millibars will have to go through that dry air in order to get there. And if precipitation falls through dry air, it ultimately starts to evaporate and vaporize as virga before it actually hits the surface. And it's why we don't see a lot of precipitation in these particular regions down in the Triad region and the Piedmont for that particular region right there. You can actually see those dry slots in motion with the 500 millibar relative humidity. If we wanted to get really deep convection, like deep snows, and this is one of the primary reasons we're not seeing significant snowfall up in Northern Virginia today, we see dry slots in those mid-levels that are currently inserting themselves periodically into them, ultimately making it very difficult for a significant amount of convection to ever actually get up to where it needs to be, like a big solid motion of green. It's these deep greens that if those were currently over the mid-Atlantic states of Virginia, North Carolina, we would definitely be seeing a significant higher amount of convective precipitation out of this system, whether it be rain or snow. But unfortunately, we don't see that currently in any respect. Just periodic showers that we're seeing throughout the course of it. So this is an atmospheric sounding, and I took these earlier this morning. They are just snapshots of the potential what the atmosphere could look like. This is actually a snapshot of DC. Washington, D.C. did receive, I think, about 2 inches of snow this morning, and I wanted to kind of delineate why that is. So the main things that we're going to be looking at here is this particular line right here. This is 0 degrees Celsius. Okay. So that is what is essentially the freezing layer. Anything that falls above or below that layer is going to either, if it's to the right, it's too warm, it'll melt. And if it's to the left, it is frozen. So in this particular situation, we have our green denoted as dew point. So that's denoted as like moisture in the atmosphere. And then we have our red, which is the ambient temperature at that current level. So at the surface, we see here we're at 26 and 24. So the dew point and the temperature are right on top of one another, which we can safely assume. Usually that means that there's some kind of precipitation falling. There is the atmosphere cannot hold any more moisture. The dew point and the temperature are pretty much the same. And that particular region is called the elevated mixed layer. So we can see that this is some pretty deep moisture that goes all the way up. So there's no interruptions and there's no dry air. Dry air would be kind of like denoted here up in the mid-levels. We see that there's quite a big departure from temperature and dew point up at the 500, 600 millibar level. We don't see that in the 700 down. So we could safely assume that any precipitation that forms in the atmosphere from 700 millibars down would reach the surface because there's no dry air that it has to interfere with in order to get there. Excuse me. So conversely, we can look at what this is at a sounding that would be from Raleigh, in the Raleigh area. We can see that we still have that saturation, but we have, if we look at the first, we'll look at the temperature level, the freezing level, the 0 degrees level at this current rate. And you can see pretty much from the surface here, it's 38, 36 degrees. So obviously not above freezing. Anything that falls would be rain. But we also see a little bit of a dry slot right here at the 850 millibar level. So any precipitation that would form here at 700 would have to fall through this dry air that we see, denoted by the separation between the temperature, between the ambient temperature and the dew point, in order for it to fall. So there very likely was precipitation that fell through this, and I know there was some rainfall earlier on in the day today in Raleigh, but it was not a significant rainstorm, just because any rain that did fall, a good percentage of it did probably evaporate as it went through the lower parts of the atmosphere, and then probably had some coalescence going into the lower parts into the 950 region of the atmosphere at the surface. So ultimately, temperature did not do it any favors, and then also anything that did fall, and there was an area up in the higher echelons of the atmosphere that probably did fall as snow way up there in the sky, but as it went through the dry slot, almost indefinitely evaporated. Anything of residual came down as rain this morning. So this is the kind of stuff that we look at when in terms of trying to figure out in real time, or nowcasting, not forecasting, we're nowcasting when winter weather comes our way. Essentially, we want to look at these soundings to be able to denote what type of precipitation that we are going to see, whether it be sleet, freezing rain, graupel, ice, snow, rain, whatever it might be, hail. These are all things that can be denoted through the sounding. So just wanted to give them a straight answer as to why we did not see snow in that particular region this morning. We're going to take a look ahead at what we're expecting over the next few days by comparing our two primary flagship models. We have our American GFS on the left and our European counterpart on the right. Taking a look at what we're expecting going into the rest of the day, we see that scattered showers making its way through and off the eastern seaboard, and high pressure ultimately building in behind it. Now this is going to be, and the models are in pretty significant agreement now on this. We have the high center that's ultimately centered right on top of us in the southeast, right, on both of the models. And high pressure moves anticyclonically, which is clockwise. So we have motion like this, generally, across the whole of the 48. Generally speaking, it takes a while for it to activate, and ultimately, if we're centered over this particular region, we aren't getting much of a circulation at all. It's just kind of it's kind of just sinking air that's on top of us. So if we are under high pressure, we are expected to experience sinking motion in the atmosphere. Since there is so much pressure, high pressure is just a matter of saying the weight of the atmosphere. There's a lot of air that's right above us in that sense. So naturally speaking, it's putting a lot of undue pressure on the atmosphere, and there is let's see, like this is the upper echelons of the atmosphere, and this is the surface. And then we'll have divergent air at the surface, which doesn't do anything generally except to prohibit any clouds from forming up in this region. So we're going to expect clear skies, and ultimately it'll shield us from any radiation that we would be receiving from the sun. So we're not getting any outward radiation or anything that's coming in, because we're being shielded, and a lot of it's being reflected by clouds up here in the sky. So we're already not getting a lot of heating, but that also means that at night, the clouds also retain heat, because little does a lot of people know, the Earth actually radiates a lot of infrared heating at night. And if this is the surface, and this is the middle of the night, that surface, instead of getting trapped underneath a cloud deck, which we would see if we were under low pressure, we would get the opposite, because those clouds are not here in this particular circumstance. So instead of that energy being trapped, all that heating of the day that we would be otherwise receiving gets irradiated out into the atmosphere. No matter pretty much what it is, no matter if we receive solar radiation or not, the Earth will still radiate heat away. So in this case, we didn't receive any radiation from the sun during the day for the most part, and we are going to be having no clouds as we go into the evening hours and overnight, which means that we're going to be radiating quite a bit of heat and not retaining any of it as we go forward in time, which was going to open us up to some pretty severe cold in this particular region as we move forward in time. So we'll look at temperatures here in a little bit, but ultimately we see high pressure dominating overhead. Now eventually that high pressure will start to move off. We have one little perturbation that'll come through here on Thursday and Friday. It will be interesting to see ultimately what the end result here is for the Western Appalachians, because the upper level vorticity is still going to be largely the same as we move forward with our streamlines. Ultimately, it's going to be a little bit more of a zonal flow, so it's kind of like the atmosphere flushing itself out in this particular circumstance. But then after this moves in, we have high pressure start to move in once again. If it'll load, please load. Yep, high pressure moves in once again, and both models are in concurrence with that. And more that it gets centered over the eastern region of the United States, more sinking air that it'll be opening itself up to. Less of a cloud deck is in place, and it'll get just even more brutally cold. So this is going out until Sunday. So this is probably the last day of warm-ish weather that we're experiencing here in the Southeast, because we'll soon be dominated by high pressure as we move into the weekend, and ultimately be opening ourselves up to cold weather. But here's the kicker, and we alluded to this a little bit last week, that high pressure eventually starts to move off and into the central Atlantic, and as high pressure moves in that general direction, what ends up happening? We ultimately have the high here, and then cyclonic motion starts going in this direction, and ultimately this is the end result. We start to open up our moisture stream from the Gulf, and this is going to be our next primary, our next weather maker, assuming that it can get a piece of the energy that's coming off of the West Coast here into the early parts of next week. So that's what we're going to be looking at. And we move forward in time just to see how big of a moisture convergence this is. And you'll notice that the rain-snow line is way up north now. So the Midwest is experiencing rain, snow, and this channel, this low-level jet, as it were, is going to be making its way all the way up. So much forcing and energy gets put up into it to make all this moisture that's over the Gulf to go straight up the Mississippi and up into the Minnesota, even up into the Canadian prairie. So quite a powerful system. And we're going to have to watch it very closely in terms of any severe threat that might be coming next week. But ultimately, because of the high pressure, not only advects in moisture, it also advects in the air temperature that moisture is currently in place. Warm air will start to begin to dominate as we move forward in time. Not a lot of agreement in terms of what that looks like in terms of severity for both of the models, but ultimately we know it's going to be a wet middle of the week for us in the Southeast due to this particular system. Now, one of the things that I generally wanted to discuss today is the North Atlantic Oscillation, which is a teleconnection that ultimately tells us about up to 14 days in advance based off of where current highs and upper level lows are placed in the atmosphere, what we are to expect from a moisture and temperature scheme. So in this particular circumstance that we're looking at right now, we'll take a look at our 10-day. We can see that the NAO, and this is the index, it's just a unitless index. If it's positive, it means one thing. If it's negative, it means the other. And in this particular, and we'll get to what those mean here in a second. So currently, the NAO has been circulating, kind of oscillating, as it were, between positive and negative, and that's been a largely big indicator of where we get our weather systems going into this. Now, this occurs over the course of weeks, okay? So you can see this is the beginning of December. NAO is generally negative, and then we go into the Christmas time parts of the year, and it's generally very positive, and then it dips again and we get our major storm systems here in the U.S. Here in the middle part of January, and now the forecast in these ensembles is saying that it's generally going to be quite positive moving forward in the next couple of weeks. And now, what does this generally mean? So if it was NAO positive like this, we would expect Greenland and the Hudson Bay region to be generally cold and hold more sea ice. Ultimately, that is high pressure that sits over top of this particular region, and it starts to advect warm air via the Gulf or the subtropical jet into the southeast. So we warm up quite a bit, and that moves off over into into Great Britain and the northern European regions to make them more warm and wet. So ultimately, it's this cold air over Greenland that we are generally seeing more of an evolution toward, and we can see that denoted by our height anomalies here. So this is currently what we're looking at right now. We see, generally speaking, quite a bit of cold air that's going to be moving over Greenland over the next couple of days. So we can see here we have generally speaking, anomalously warm air that's currently over the Hudson Bay. Now, anomalously in the sense that it's still very cold. It's just a little bit less cold than normal up there in terms of average temperatures. And we see these little dips that are going to be making its way here in the 500 millibar range. But as that occurs, you can see in Greenland, it starts out in these really dark reds, and then it'll start to shift, and that cold air starts to form right on top of Greenland and starts to form quite a significant high pressure system over that particular region. And whenever we get that cold and dry air over Greenland, what happens then? It means that we get ultimately the flow in a counterclockwise rotation, and ultimately on a macro scale, our general flow will come from the subtropical jets. So as we move forward in time, and that centered region of cold air gets centered over Greenland, ultimately we see a lot of air getting pulled in from the jet up into our particular region here in the southeast going forward. So it's just one of those teleconnections that we need to look forward to, and that's kind of what the Climate Prediction Center is probably going to be looking at in terms of a high amount of moisture return, which we've already talked about with our flagship models, due to that high pressure at the 850s and 850 lower levels of the atmosphere, but also in the upper levels, we're experiencing some significant height falls up in Greenland, which is generally indicative of some better warm air advection coming in from the far eastern Pacific and up over Mexico and into the Gulf, which is not necessarily something that we've seen recently, as most of our cold air advection has come from the Canadian prairie and the plains, due to and kind of sucking in that cold air from the polar vortex that is displaced at the moment. So quite a bit of a pattern change that's coming our way here in the next 10 days. Definitely going to have to keep an eye on it and see if it translates to any severe weather, because if any of these main lows, and this is already something that I'm curious about going forward, if any of these lows, and this one's dipping way down south, make its way down into this particular region and starts opening up the Gulf with a high amount of vorticity associated with it, the Mississippi River Valley region and points eastward could experience some severe weather going into next week. And we can also see this denoted in differences between the upper levels here. It might be a little bit easier to be able to see. So we have cold air currently situated over us right now, and a generalized closed low that's currently spinning over the Hudson Bay. And ultimately, that is what is responsible for our cold air currently. And as we move forward in time, and I'm actually going to go forward a full week here to see what it looks like then, we see that cold air has strengthened and moved off into the North Atlantic and over Greenland. And where's the wind coming from in this particular respect? No longer coming from the northwest. It is fully coming from the subtropical jet and the Caribbean and the Gulf of Mexico here in the southeast. So definitely whenever the NAO goes positive, like it's being forecasted to do, no matter which ensemble product you look at, this is generally speaking something you can look forward to in the next 10 days, a little bit of a warm up and probably a little bit more moist. And this is also reflected by the Climate Prediction Center's 8 to 14 day temperature and precipitation outlook. You can see generally across the whole of the United States, but particularly up in the upper Midwest and the eastern seaboard, it's significantly higher than average temperatures. And then also we see that opening up of the Gulf moisture up in Texas and the deep south, and that will slowly start to spread over into the East Coast as we move forward in time. Ultimately, though, that is what we're looking at for today. Once again, my name is Zach for Great Atmosphere. I do primarily short-term and medium-term forecasts for the southeastern United States, and I'll be putting out forecast videos like this every weekday as much as I can. I appreciate you if you can possibly subscribe. If you're particularly in the southeastern region, this is obviously information that's relevant to you. Hopefully I can evolve this over time into a better product for everybody, but ultimately it's just something to keep my forecasting skills sharp, and I appreciate you coming along for the ride in the first place. So until then, I'll see you tomorrow with another forecasting video. Thank you for tuning in. See ya.